Today I'm gonna talk about the LLM Visualizer tool that I have built using Flask. I wanted to always check like how these LLM models understand these sentences. Right. These like right now I have used BERT. It's an AI language model. This powerful tool is going to reveal some hidden patterns in how these models process the text. Okay. So I'm just gonna copy some text. So this particular visualizer tool demonstrates three key aspects of NLP. One is 3D semantic embeddings, attention mechanism, and tokenization process. So let me walk you through what happens. So this is the text I'm providing. So let's first look at the tokenization process. Okay. Sorry, process. So here I'm using the model BERT model for getting the tokens and creating the vector embeddings. It has a vocabulary of 30,522. Okay, so the input length, if you see, I'm providing 309 characters, and how many tokens are created out of this text? It's 62, and average tokens per word is 0.20. So original dimension of this vector, whatever vector it was going to create, 768. That's from BERT model. So in order to make it easier to visualize on this tool, I have reduced it to 3D dimension, and then use it for plotting on my end. And this is the attention metric details. So this is created based on the number of tokens that are generated. So here tokens generated is 62, so attention matrix is 62 cross 62, and the max attention that we have seen is 0.1799, and minimum attention is this. Okay, so now let me walk you through the tokenization process. So what we're going to do is we're going to input a text. So here if you click on next, it will show the tokenization results. So all these words, cats and dogs, humanity, two most popular domestic companions, this is what it is there in the statement basically. So you can see some things like highlighted words. So what are these? So these are called subwords. Okay, so when there is a complex word observed, then what BERT or any language model does is it is going to split those into different words and then make them into multiple tokens. So companionship is currently split into companions and help. So this is a subword tokenization. Here one more occurrence that we say, sufficiency. STA is a full token, and this is subword. Okay, this is called a subword tokenization. And each of these token gets a unique ID, and then this model converts these tokens into high dimensional vectors. Okay, so this is the unique ID that we got, and the ID ranges from here to here, 1012 to 29,125. Okay, so if I go to next tab, I can see the vector embeddings. So I said like after it provides the unique ID to each of the tokens, then it is going to create a vector embedding. So here we can see I'm seeing only like 3 dimensions over here. Okay, so these are the vector embeddings. I'm just showing you for just for understanding how the vectors look like. Okay, so this is reduced to 3D just for visualization process purpose. Now 3D embedding visualizer, if you see like this option, if you don't want to see what that label is, then you can see it like this as well. And I want to show you the token label so that I can understand like how BERT is processing all these texts, all these words, right? So so each of these colored point, right, they represent a word token from our text. And our text was about cats and dogs being companions. So the positioning reveals like how the model understands semantic relationships. So all these versions, like why they are mentioned there. This is a 3D space. So where that plays based on that semantic relationship, semantic relationship is built based on these versions. Okay. So now like for example, let's see this particular cluster. If you can see here, dogs, owners, loyalty, companions, training, all these are kind of together, right? They're positioned together. So these describe the characteristics of dogs. As we all know, dogs usually are very loyal to their owners, and they are very good companions, and they can be usually trained, right? Cats cannot be. And also you can see dog is placed here and cat is placed here, like very far from here. Like although they are similar type of animals, what I have given the statement, that is not about the same type of animals. This is about companionship, like how is the dog companionship, how is the cat companionship. So what are their characteristics? So that's mainly about that, the sentence that I have given. So hence you can see the semantic, like that's how the semantic relationship is captured. Like a bird has intelligently captured those, and we can see it in this vector 3D space. Okay. And also you can see all these most popular, like while, to, and then for, they're all scattered around, right? So so what are these? They are called as functional words. So they are distributed throughout the space because they are semantic connectors between different concept clusters. So this might be one cluster, and there might be another one cluster here. So all these are like connected. They have to be connected together. How do we connect words? We use the pronouns, or we use these functional words, right? So it is capturing those semantic connectors as well between the different concept clusters. Okay, and regarding this color bar and the color pointers, purple is how we are starting, like the starting sentence. So that is purple, and at the end of the sentence, it is going to go pale yellow, yellow color. Okay, and in between, medium is around green shade. So this represents each word's position in the original sentence. And next, if you move ahead, yeah, I have attention visualization as well. So this is attention heat map. It shows a sophisticated pattern of world relationships. Okay, so this particular diagonal line, this diagonal line that we have, it represents self attention. That means each word paying attention to itself. Okay, so notice, you can see so here we have cat to cat, it's 0.1799. I think that's the highest attention that we have. And one more, we have while also has a very high um, self attention. Okay, another striking feature that we can see in this attention map is the cross attention. So here, this is diagonal line, that's self attention. So basically each token paying attention to each of it, and then itself. And these are vertical lines, they're cross attention. So here, what is that is like all these are attention hubs. Okay, if you can see the words, they're and, offer, with, why, they're all functional words. Okay, so they're both receiving attention from multiple other tokens and distributing their attention broadly. Okay, so this dense interconnected pattern reveals like how the model builds a comprehensive understanding of world relationships. Rather than focusing on just a few key connections, it creates a web of attention that captures both local context and global sentence structure. The numerical values that we have over here, they show attention strength with higher numbers indicating stronger connections between the tokens. Okay, so all these other words are there above the threshold. So some of the words that above the threshold, that's why they're outside this particular map. Yeah, that is about this project. Thank you.